Assalamu alaikum warahmatullahi wabarakatuh. This is Ahmed Fawzi. Welcome to Lab 11 of EE235 Electronics and Microcontroller Lab. This is Logic Circuits lab. We are going to talk about the binary concept in the beginning. The term binary refers to that we have two states, either 0 or 1, high or low. A logic gate means that there are several inputs and only one output. The output is activated by particular combination of the input conditions. For example, if we have two inputs, so if we have the logic circuits or the logic gate is AND, so both inputs should be on in order to activate the output, and so on. Logic is the ability to make decisions when one or more different factors must be taken into account before an action is taken. Here we are going to talk about three major or basic logic circuits, NOT, AND, and OR. NOT operator means inverter. If we have input which is 1, the output will be 0, and if the input is 0, the output will be 1. So it inverts the input. For AND gate, it means that all or nothing operator. Output high only when all inputs are high. For OR gate, any or operators, it means that the output will be high when at least one of the input is high. This is inverter, this is AND gate, and this is OR gate. And here is the truth table for these logic functions. We have AND, and if A and B are 0, we will get 0. A0 and B is 1, output will be 0, 1 and 0 will get 0, 1 and 1 will get 1. And on the other hand, on OR gate, we will get all outputs are 1 when either of the inputs is 1 or both of them are 1. But for 0 and 0, we will get 0. For NOT, we will flip the logic. If the input is 0, we will get 1. If the input is 1, we will get the output 0. And here is the Boolean expression. AND means that dot or the product, if you would like to say that. A dot B means that A and B. A plus B means that A or B. And here is the complement of A, means it is not gate. Here is the same thing, logic statement. Y is 1 if A and B are 1. Y is 1 if A or B is 1. And Y is 1 if A is 0, and vice versa. Here we are going to talk about the physical implementation of the binary operators. For example, if we have here AND gate and we have two input switches, switch A and switch B. So if they are both open, the light will be off. If both are off or closed, so the light will be on. And it will be mapped as hardwired circuit, like series combination of two switches. We have switch A connected in series with switch B, and both switches should be closed in order to get light on. For OR gate, we have here two switches, and it mapped to a hardwired. Two switches are connected in parallel, and if one of these switches is on, the light will be on, and if both are closed, both switches are closed, the light will be also on. For the hardwired circuit of the invert or the NOT gate, it will be normally closed push button. This is the map of the NOT gate in the hardwired circuit. So here in the hardwired circuit, it is, if it is not pressed, which means it is 0, so we will get light on, which is 1. But if we press it, and this will become 1, and the light will be switched off, and it becomes 0. Here is the same thing. We have the truth table, we have the logic implementation, and the Boolean expression. Let's take an example. We have here three inputs, W, B, and D, and we have three gates, not and or. So in the beginning we are going to get يعني so in order to get the output here we must to split our problem to several stages. This is the first stage, this is the second stage, and this is the third stage. In the first stage we have here D, and D is connected to NOT gate, so it means that on the output here we will get D prime. After that D prime and B are connected to AND gate, so it means that and it means a multiplication, or B and D prime. After that, in the third stage we have here B multiplied by D prime is connected with W with OR gate, so it means that W plus BD prime. This is a graphical implementation of Boolean logic, and here we get the final expression of C or Y here in the output. In this example, we are going to develop logic gate circuits from Boolean expression. So if you have here Boolean expression or Boolean equation y equal AB plus C, so first we are going to make AB. AB means that I have two inputs, A and B, and they are connected with AND gate. And after that, A and B are connected with C with OR gate. So here we have plus, so AB plus C, this is OR gate. Same here, let's make the vice versa. We have here the logic gate circuits, and we want the expression. Here we have AND gate, so it means that BC here. BC is connected with D with OR, so D plus BC. After that, this expression is connected with A by the use of AND gate, so it means that all of this will be multiplied by A. This is the output, and which is the same here. Here we have A plus B, there is OR here. We have C, we have D invert, and they are connected to AND gate in the output, so it means that A plus B all multiplied by C D invert. Same here, we have A invert because this is NOT gate, and here we have B invert because we have NOT gate here. But let's check here the first AND gate. It takes A invert, and also here it is connected to B, so A invert B, this is the output of the first AND gate. Here we have B invert, and this wire is coming from A, so it means that here we have A. So the output of the second AND gate is A invert B. So the output here is connected to OR gate, so A invert B plus A B invert. This is Y output. So here is a second example. We have A and B connected to AND gate, so it means that A, B here. Here we have A invert or A complement. Here we have also B complement. Okay, it means that after the AND we have here A dash B dash, and they are connected to OR gate, so it means that AB plus A dash B dash. And we are going to develop the truth table for this logic circuits. So we have here AB and we have A dash B dash. So Let's at the beginning make two columns because we have only two inputs. So I will make B 0 1 0 1 and A will be 0 0 1 1, and if I have third input I will make 0 1 0 1 and so on 8 times. Here will be 0 0 1 1 0 0 1 1, and the last one will be 4 zeros and 4 ones. But let's take here the two case scenario. We have two inputs. After that we are going to split it. We have here A dash, we will get it, and we have B dash, we will get it. A dash means that 0 0 will become 1 1 and 1 1 will become 0 0, and so on. For B dash, 0 will become 1 and 1 will become 0, and so on. After that I am going to get AB, so it means that A and B, 0 and 0 will be 0, 0 and 1 will be 0, 1 and 0 will be 0, 1 and 1 will be 1. What about A dash B dash, which is this? I will multiply or get AND between A dash and B dash. 1 and 1 will be 1, 1 0 will be 0, 0 and 1 will be 0, 0 and 0 will be 0. After that I'm getting the plus, which is OR between these two columns, okay, which is the output Y. 0 or 1 will be 1, 0 or 0, 0, 0 or 0, 0, 1 or 0 will be 1, and this is the truth table for this example. When we are going to implement this in hardware, we are going to have three different ICs. The first IC called AND, and will have this number on it, 7408. For OR will have 7432. For NOT will be 7404. Let's get deeper inside the AND gate. We will have inside this IC 4 AND gates. From the notch we will count 1, 2, 3 and so on until 7, and after that 8 until 14. For the first AND gate it has two input, 1, 2, and the output will be 3. For the second AND gate will be 4 and 5 as inputs and 6 as outputs. 7 will be the ground, and here are the same. This is input 9 and 10 for the third AND gate, and 8 is the output, and so on for the fourth AND gate. And we have 14 as VCC, and it will be connected to 5 volt, and 7 will be connected to the ground. Same applies for the OR gates. We have 4 gates here. 1 and 2 are inputs for the first OR gate, and 3 is the output, and so on. And VCC and ground are the same. For NOT gate, we have here 6 NOT gates inside this IC. 1 is the input and 2 is the output of the first NOT gate, and so on until reach to the 6 of the NOT gates inside this IC, and we have 14 and ground as VCC and ground. So to make this circuit in hardware, for example, we have here A B dash, because we have here B dash, and A with B dash connected to AND gate will be A and B dash. To make this, it means that I have to use NOT gate, and also I have to use AND gate. Okay, so first for NOT gate I need to invert B, so I will connect B here on 1 and will get B dash from the second leg. Okay, for the AND gate we have here A is connected with B dash, so the first terminal, which is 1, will be connected to B dash, which is leg number 2 from the first IC, which is NOT, and the second one will be going to connect it to A terminal. So I will get the output on the third leg of the AND gate. and I will connect the third leg here to a lid. So if the lid is lightened, so it means that the lid will be on and the logic gate value will be 1, and if it is off, so it means that we will get 0. And we will use the Elvis kit, and we will use this digital writer software on the PC. And here we have the inputs. Okay, so this is the first input, A 0, B is 1, C is 2, and so on. And if you make this off, it means that it is 0. If you click here on this switch, it will go up, and it means that it is 1 right now. So you are able to test different case scenarios. For example, if I have this table 0 0 0 1 1 0 and 1 1, we will test the 4 scenarios by letting 0 and 1 here, or A and B both are zeros, and check what will be the output. If the lid is on, so it means that we will get here 1. If it is off, so it means that it will be 0. After that, this is A, this is B. After that, I will test the second case scenario. A is 0, so I will make this as it is 0, while B is 1, so I will switch the second switch to be on and check the output of the lid. After that, I will make 0 as 1, or A as 1 and B as 0, and check. Last one, I will make both are on, A and B, and check the lid output. And of course you have to run in order to check the influence of the logic circuit on the lid as output. So you are going to make this example on your lab. Here you are required to develop the Boolean expression of this circuit, and also to construct the following truth table and get Y, and also to test the case scenario. You are here going to connect 3 ICs because we have AND, OR, and NOT gates, and you are going to use digital writer in order to run the simulation. Make, for example, 0 1 1 and check whether the lid is on or off, and so on, and fill in the truth table. Note that when you are going to connect the ICs on the Elvis kit, we have here VCC is 5 volt, and all of 14 leg of these 3 ICs will be connected to 5 volt, and all of the ground will be connected to the same line here, which is ground. And here DIO 0, 1, and 2 will be considered as A, B, and C as inputs. Okay, and for the output will be connected to one of these lids, lid 0, lid 1, lid 2, and so on. You will connect the output to one of them, and check here. For example, in this test scenario, A is 0, B 1, and C is 1. So the output here is on, which means that Y is 1. So this is also another example you could test yourself. We have here another circuit, and you are required to get the output Y using the truth table method, and also get the Boolean expression. In the second part of this experiment, we are going to talk about Boolean function. Boolean function express the logic relationship between binary variables, and it is evaluated by determining the binary value of the expression for all possible values of the variables. For example, we have here the output F1, and this is the first term, and this is the second term. The second term has AND gate, and between the first and second term we have OR gate. So there is something called Boolean algebra, like any other deductive method for mathematical system. So we have here some postulates and theorems of Boolean algebra. For example, if I have x plus 0, it will give me x. If I have x dot 1, x and 1, we will get 1, and this is called identity. And so on. If we have x or x prime, it means that I will get 1. If I have x and x prime, I will get 0, and this is postulate of complement, and so on. Also, we have theorems here. If I have, for example, x or 1, I will get 1. If I have x or 0, I will get 0. And if I have x prime and x prime has a prime also, I will get the basic x. Now I need to use this table to simplify this Boolean expression. Okay, so I have x prime y prime z plus x prime y z plus x y prime. So now I have x prime here and x prime here. Also I have here z and I have here z, so I will take them as common multiplier. So x dash z will get the remaining y prime plus y, and also I will get this term as it is. From the table, y prime plus y prime plus y, I will get 1, so this thing will become 1. So I will left with x dash z plus xy prime. So when I ask you to make the circuit representation of this Boolean expression, you are required to have 3 inputs, and you will have here 2 NOT gates, 3 AND gates, and 1 OR gates. But in the simplified form that we reached here by using the table of postulates and theorems, we will only have 3 inputs with 2 NOT gates, 2 AND gates, and 1 OR gate. So the simplified form will give me simplified version, and the output here will be the same. The basic form and the simplified form will have the same output of the truth table. So in part 2, you are required to simplify this expression. It has 12 literals, 12 literals here, and you are required to have only 4 literals after simplification using the postulates and theorems. And you are here required to get the simplified one. After that, you are going to draw the circuit for both y and y simplified. After that, you are going to make comparison between number of gates required for y basic and y simplified, and write your comments on the advantages of using y simplified. After that, you are going to make or construct the truth table for both y and y simplified, and construct the circuit in hardware and validate whether this truth table is valid in hardware or not. So this is the hardware, and after that you are going to check here these things and validate whether y and y simplified are same as the output here in the circuit. That was the last lab of EE235, and I enjoyed to teaching you this lab, and see you next time inshallah.